Hello friends, we are continuing with the series of videos on HPC and cuda, and we have done a series of 10 videos earlier. Now we are continuing with the 11th video where a symbol addition program using cuda and a vector addition program using cuda both will be executed and also will be profiled to see the difference in speed, etc. So you can see in this screen actually this is going to be doing a simple addition. A is equal to 2, B is equal to 7, C has to 7, it has to come 9. So you know the process. This has been already discussed. The kernel is running, the kernel is launched, and add_num function has got 3 variables A, B, C. They are passed as memory units. So start with the program. Main ABC is the integer. You have the pointer to ABC. Then you are allocated the memory in the star pointer, that is at the device far off memory, and that means this much space is allocated for A, this much space is allocated B, this much space is allocated by C. Then you are initializing 2 and 7, A and B in the CPU. This is in CPU, and then you are copying A into the host, B into the host, and doing the kernel launching, and where A and B will be added and C will be the result, and C result is brought back using cuda copy into the CPU, and then that means into the serial program. Then you are freeing the use memories to avoid segmentation fault, etc. So when you do the profiling of this, it looks very simple. You can simply compile it using nvcc symbol_addition.cu. That is a file name. Then you get an a.out and you say nsys profile a.out. It creates a file called report3.nsys.rep in this particular case. This you can take it to Windows and analyze in the NVIDIA Insight System software. So this is a screen look like. You can see 2 GPUs are being used. You can stop the video and see the details. Now this is the single the GPU details, and also the CPU details. CPU details are here and the GPU details are here. GPU details are again here, and now the screen is going to screen is looking like this, where it is executing in 2.2 microseconds. Then their operation has been done, and now we go into the next program, and you always remember this 2.2 microsecond here, and you go into the next program, the more bigger program, where ABCs are now arrays. Actually the only difference is they are arrays. And you know the good thing in arrays or integer, the difference is the starting address is always common. So it is a pointer based manipulation is easy in arrays or numbers, integers. So you same thing, you are allocating memory, you are initializing A0 by 0, A1 by 1, A2 by 2, like that. You can initialize the values by simple serial code. Then you are copying the A, B, C into the remote memory, and using M is equal to that number of blocks 512, though we don't need so much, and we have fixed M is 512 and N is whatever size of A, and block is calculated this, and using this formula block comma M, you are launching a kernel, and result is brought back using cuda copy, and you are releasing all the memories and printing out the results. So see here, you can see that same process, nvcc vector addition.cu, you are getting results right. Now you do a profiling using nsys profile.a.out. When you do this, again output comes, at the same time profile file is also generated. Report 4 is generated. When you take this file into Windows and NVIDIA Insight systems can analyze this dot out. The report file, that is nothing but the dot out content. So you see that these are things, different screens which you have seen earlier also. So the GPU information, etc., etc. Now the most important point is this is taken 2.3 microsecond. So now we will do a comparison of array means bigger problem, simple integer means it has to be simpler problem. Let's see how much time difference it takes. So we have done an extra hello world program also, like we have seen in the earlier videos. Simple printing hello world inside the kernel, one line. So that had taken 48 microsecond. And when we did some mathematical manipulation of simply addition of two variables, it took 2.2 microsecond. And when we added three elements in an array also, it took a 2.3, which is almost same. So even if you increase the number of elements, do a little more complicated calculation, the time is not proportionally increasing. It is very, timing friendly when it comes to calculations. So whereas there is no calculation in this, it has taken more time. So that is all about this video. But we will go into the demonstration of this now. So I am connecting into the HPC machine. You are getting a dollar prompt, and you are going to now run srun minus capital N1 means one node we are allocating for a GPU is equal to, we are going to call two GPUs actually, GPU 2, because every node has got two GPUs. Now this is a standard command. When you do this, you got now you can skew minus u dollar user will give the allocated node. You know that RPGPU 003 is allocated. Now go to the next command, that is module node spec. This is an environment which is required. So then every module is loaded through spec. So now you executed that environment command line which we got. Now spec load your CUDA things you do. Now you have to also say exact version of the CUDA. So for that you have to cut and paste the string also along with. So after doing this, now you are well set actually to execute the program. And you can see the program. Simple addition.cu was it's only adding A and B. So you are going to add 2 and 7, going to get 9. Execute this program, then we can see the next program. You can see the next program. Okay, now so this is, here you have an array. So right now we have only 3 elements in the array. You can see that actually A0, A1 and A2, because the I is varying between max number of elements. Number of elements we have set as 3. You can increase also, but right now only 3. Now let's profile this program. So what you do is NVCC. First you do this execution, create a .out file. After that, you have to create a report out of this .out. So you will create a report by nsys profile .out. So it will going to give you a report file which you can take. You can take it to the Windows machine through a simple Win FTP, that is Windows FTP utility. There are many utilities, so one of them we will use actually for that. Here it has created report 5. So now report 5 is now just pulled in from right hand side HPC to the left hand side Windows machine. That simple it is. And after that you click on that report 5 file. Simply you can hit NVIDIA Insight Systems command and then go to the kernel summary. You get see it is taking 2 microseconds only. So now looking at this, that's all actually. So other details we have already discussed actually about other profiler. You can see other details, but we are more interested in how much time it is taking. So if you look at the earlier slide, the comparison, see it was taking 2.3 microsecond. This is all margin of error here and there. So approximately 2 microsecond is taken. So it is taking such a, this is a comparison, 2 microsecond, 2.3 microsecond. Now we'll see in the next videos, if we increase the number of elements to huge, how much it is going to change. Right.